What up? How's everyone going? In today's video, we are going to do more calculus homework. Let's do this. I also got an unfinished burrito from yesterday that I'm also going to eat because why not? Very quickly, I still got to watch the lecture. So I won't share my screen for the entire time, but I want to show you my grade for my last exam that I just did this morning. Um, I got a 93. So that's pretty cool. There were 16 questions that 16 questions and I got I think 15 of them correct. Yeah, it's pretty easy. So today we're gonna continue our homework of calculus. Yeah, here with my work for the exam. But we're gonna continue because why not? So here we're going to see more intricate derivatives and differentiation rules. So we only got 3 assignments to do before a quiz, so we should get this done quickly. Derivatives of inverse functions, of inverse trigonometric functions, and then derivatives of exponential and logarithmic functions. So that'll be cool to have a refresher on exponents, logarithms, trigonometry, functions, all of that. Yeah, I saw this in time. Hello. What's up? How are you? It's good to see you. So, I'm going to begin watching the lecture for today. And you guys are just going to watch me see the lecture. So, I think we got a 7-minute video to watch, and then a 6-minute video, and then finally an 8-minute video. So, that in total is going to be like 15, 20 minutes, I think. So, it won't be as long as other times where I had to watch like a 30-minute video. Yeah, I'm just getting mentally prepared. And I'm wondering if I should get a plate to eat this burrito. I don't know. Probably I should. I'll be right back. Awesome. Let's do this. Yeah, I don't think I'm gonna write anything right now. So I'm just gonna watch and eat. Taste the burrito. Ooh, let's go. It's a little cold, but it's fine. I mean, it looks actually really good. Okay, let's do this. So I'm just gonna stop screen sharing. We'll proof. Awesome. All right, let's do this. Okay, I see. Hmm. Yeah. Hmm. Unique output to each input, meaning each input must have a unique output. That means Two inputs can't have the same output. I see. Hmm.
Yes.
Right. The domain X can be anything, yet the output is only going to be from -1 to 1. Right. G of X. Mm-hmm. Mm-hmm. Negative. Mm, hmm. Hmm. Well, you'll get. Can you get a negative number? You can't get a negative number, can you? So you'll probably get something like 0, although but it'll never reach it. All the way to infinity, I think. Probably. Hmm. Oh. Okay. So the radius r of t. Right. Squared. One. Mm-hmm. Oh, one. 5. Mm-hmm. 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 Cool. Okay. Mm. I see. All right, let's go to part 2 now. I'm feeling a little thirsty. Yeah, let's not procrastinate. Let's do this. Okay. All right. I'll be right back. I'm just gonna put this back. I'll be right back. All right. We're back. Oh, let's do this. Just gotta wipe this entire desk. All right. Interesting. Interesting. Okay. Mm-hmm. Interesting. Okay. Mm. Ooh. Okay. Is that? I see. Yeah. Just why? Okay. All right. Let's see. So inverse of f of x. Um. So f of x is going to equal y, and f inverse of y, what's, oh, well, that's going to equal x, right? I see. Yeah. Hmm. Yes. Well, I'll do this thing. There we go. Okay. Yeah. So the input of f when plugging in x is y. The input of the inverse of f when plugging in y is x. Sure. And these are equivalent. The domain of the inverse of f is the domain of the inverse of f, uh, and the range of f. So the range of f is the domain of the, yeah, right. The output values of f are the input values of the inverse of f. That makes sense. Yes, ma'am. Has exactly one. F is invertible if every output of f has exactly one corresponding input. Oh, if every output of f has exactly one corresponding input, I see. Such a function is called a one-to-one function. Yeah, yeah, I remember seeing that. And digital logic. It was a cool class. Uh, then graphically, we can use the horizontal line test to see whether a function has an inverse. Horizontal, so horizontal or flat. If any horizontal line cuts across the graph more than once, what does it mean cuts across the graph? Oh, oh, I see. So if if we have like a parabola, yeah, if we have like a parabola, I see. Like if we have like a parabola, and so parabola is like this. If a horizontal line crosses it more than once, then the function is not one-to-one and will not have an inverse. Right, because the horizontal line will touch it two times, not one. I see. Gotcha. So a parabola is a function, but it has no inverse. But then if we have like a sideways parabola, I don't know if it has an inverse or not, but we know that that's not a function because that means that for one x we have two y. What? No. Sorry, for one y. Sorry, for one y we have two x. No, I'm actually not sure. For one y, I mean, for example, if we have like a y5, right? Yeah. No, you have no x y. There we go. So we have like a. I see. Oh, so is that not a function as well? Because wait, what did he say in the last video? Um, assigns a unique output to each input. An input has a unique output. Each input has a unique output. Each input has a unique output. Each input. Right. Two inputs can't give the same output. That's right. Oh, that's right. Yeah. So that's why a sideways parabola is not a function because one x will have two y's. And that's by definition not a function because one x would have two outputs. An input must have a unique output. Is that what I said? An input must have a unique output. That means two inputs can't have an output. Two inputs. Two x's can't have one. Oh, my bad. Sorry. No. Two inputs can't have one y. Two inputs can't have one y. Can't share a y. Yeah, that makes sense. 4 and 5. 1. Oh, so that's why you can have like a horizontal line or what? I see. No, no, no. So I guess a parabola is sorry, like a sideways parabola is a function. Hold on. Let me just ask ChatGPT real quickly. If whoops, if no, valid function. Oh, can have two different inputs that give the same output. Interesting. Oh, a function cannot give two different outputs for the same input. Oh, obviously, yeah. F of x equals x squared. We can have 2 and -2 as inputs, and that will give the same output. That's completely allowed. Maybe it does not have an inverse, though. I see. But a function cannot give two different outputs for the same input. 1x to 2y's. There we go. 1x. That's why so officially a sideways parabola can't have it's not a function since 1x corresponds to 2y's. All right. I get it. I get it. All right. We're good. We're good. All right. Let's okay. I see. Oh, so two inputs in our domain cannot cannot map to one output in the range for it to be an inverse. It can still be a function. So that's why f of x equals x squared does not have an inverse. I see. Right. I see. Oh, yeah. Yeah, if you have f of x equals x squared, you don't know whether x is going to be 2 or -2. So, yeah, 1 to 1. Okay. Then we want to see whether 2 x's correspond to 1 y. Oh, so we should look out for, like, a parabola of some kind. 1 to 1. Right, because 1 y will correspond to 2 x's. No, I'm sorry. Yeah, right, mhm, or 2 x's will correspond to 1 y. I see. So 2x plus so f of x equals 2x plus 7. Does that have an inverse? Um, I think so because I think so, right? Is this like a linear Mhm, gotcha. Wonder if there's like a rigorous proof. That does not have an inverse. No. So does not have an inverse. Yes. I mean, no, it's not. Yes. Oh, gotcha. So f of x equals x cubed plus 2. Cool. Yeah. Hmm. Let's see. So cube root of x minus 2. For f of x equals x cubed plus 2, um, determine, yeah, determine the inverse. So what are we trying to find? I'm trying to find uh, a function whose output x squared plus 2 is the input to get x. Okay. Okay. Hmm. Gotcha. Okay. Interesting. Okay. So, I'll see about what we learned. So, a function must be one to one in order to have an inverse. We can check if it has an inverse if it passes the horizontal line test. If a given y crosses the function more than once, then it does not have an inverse because two inputs correspond to one output. Two x's correspond to one y. Two x's correspond to one y. That's right. Yeah, and intuitively, we can't go from y to x because we don't know which one. I mean, it has two choices. Okay, I see. Oh, yeah, and a function is not valid if if one x corresponds to one y, to two y's. I see. Okay, gotcha. All right, cool. Um, yeah, domain ranges. I see. Okay. Uh, dang, you smart. Ah, thanks, man. Thank you. I mean, yeah, I'm just watching a video. So, okay, we got one final video to watch, and then we will begin doing our homework. So, we're almost done with these lectures, guys. So it won't be that boring. Here we go. Let's do it. Okay. So yeah, if we want to find the derivative of an inverse function, your first thought would be simply to find the inverse of the function, apply the derivative, and yeah, Okay. I see. Oh, so you can take the inverse of the derivative of the function? Oh, what do we want? Cool. All right, I'll see that again. Okay. Whoa, that's intimidating. Okay. So if we want to get from f prime, so from the derivative of the function to the derivative of the inverse of the function, then we do 1 over the derivative of the function evaluated at the inverse of a, where a is whatever at x equals a. Uh-huh. Okay, hold on. Yeah. F inverse of a. Yes, ma'am. Let's do it. Okay. Okay. So if we apply the formula, we get something like 1 over 2 minus sine. Oh, but we'll have to apply the chain rule as well. So 1 over 2 minus 3 sine of x, I think, times and the inverse of that, which is going to be all right. It's fine. Let's just see. Okay, I see. Okay, a a equals 1. Uh-huh. X equals a. Um. Mhm. Wait, the value of x or the value of y? Okay. Of 1. We chill, 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 what? Oh, lucky. Gotcha. Alright, so the inverse of okay, yeah, let's go back. So the inverse of a function sorry, the inverse of a function of some wait, f of something. So the inverse of f of something is gonna be is going to equal wait, what? 0. Hold on. X equals 0. My bad. So that something is gonna be the value you get by plugging it into the normal function and getting 1, I think. Okay. Mhm. Yeah. Mm. All right. Here, I'll just work through this example, and I guess I can now begin sharing the screen. Here, let's share the screen. Oh, in fact, I'm sorry. Let me stop sharing for a second, and I'll share. Let's see. I'll share. Where is it? There we go. That whiteboard. Perfect. Here. So this is where I'm gonna do my work when I can't show the problems on the screen due to copyright reasons. It's so we have a function h for which h of a equals b. Whoops, equals b, and h prime of a, h prime of a, the inverse function of h. So it's asking for the inverse function of h evaluated at b, if possible. Okay. Well, see. Hmm. Ooh. Hmm. So they're giving us the function h of a equals b, and then it's telling us h prime of a is 4. So yeah, okay. And then they want us to find the inverse function b. Okay, all right. So applying the formula, they said something like Um, so we have so we need to know prime, and they're giving us that over here. Whoops. Where do we draw? Yeah, cool. They're giving us that over there. And we also need to know the inverse function. But so we need to know the inverse function. Oh, gotcha. Evaluated at A? I'm sorry, dude. I'm so confused right now. Let's see. All right, here. I'm just going to put the video. One over F prime evaluated at the inverse of F of A. Okay. B. Yes. Wait. So we have H of A equals B. B. Oh, well, let's say, yeah. I see. All right. So going back here. Well, yeah. Per the definition. Oh, wait. We need to find prime. Sorry. Prime. So we know use this equation 1 over F prime. Whoops. F prime evaluated at F inverse of A. Cool. So let's see. So to evaluate for F inverse of A, this is equal to, oh, well, I mean, yeah, our our function of interest is going to be H. So yeah, and our variable, well, right now, we want to find H of B. So right here, this is a really B. So to find this function right here, we're gonna do H inverse of B. All right, yeah. To find H inverse of B, well, in the inverse function. All right, let's see how to explain this. Well, yeah, H of A equals B, so H inverse of B equals A. Yeah, you plug in the input in H, you get the output B, and if you plug in the output in the inverse function of H, you get the input of the original function. So yeah, I guess that's the way I'm saying it. Yeah, that probably didn't make sense, but it's okay. Yeah, so we have this. So right now we're making progress. We have 1 over F prime evaluated at A. Beautiful. Or yeah, in other words, that this is like with H, but it's fine. Yeah, H prime of A. That's not B. Wait, you can do that though? All right. Sure. Sure. Yes, that's right. 1 over. So we just plug that in, we get 4. Cool. All right, guys. Here, I think I'm getting used to more how this is going. So, yes, I see. Okay. Okay, I see. I see. All right. So, I think I'm going to begin pulling up the homework now because I think we have enough information and with more practice, that's going to be good. So, here, now I'm just going to share my entire screen. We don't need to worry about copyright anymore. Um, so where are we? Let's see. Now we're gonna pull up our work of derivatives of inverse functions. Let's do this. Uh, you're making my brain hurt. Oh, I'm sorry. I don't want to make your brain hurt. I mean, once you understand it, it's okay. What's up, Calc game? What's up, bro? What's up? All right, let's do this. So, derivatives of inverse functions. Okay, now it's time to lock in. We were eating a burrito while watching the lecture. Now it's time to to lock in. Here I'm just gonna erase all of this because we don't need it. Where is the eraser? Okay, can I just do that? Oh, nice. Okay, that's kind of cool. Whatever. Okay, 3 questions. That's insane. That's nothing, dude. Let's do this. So we have to consider the function f of x equals square root 2. Let's go. And we need to find inverse of 2. So let's see. Oh, so it's not even asking us for a derivative yet. Gotcha. Cool. All right. So um f inverse of 2. Yeah. We need to solve for x, I'm guessing, right? Y. We know that f inverse of y is going to equal x. So we want a value over here that when plugged in, no, 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 I'm sorry. Let's see, no, no, no. We know that f inverse of this will give us, yeah, what will that give us? Yeah, I don't know. Oh my goodness. Yeah, now my brain is hurting as well. Hold on here. Um, so if f of x equals that, so um, we need to determine the evaluated at x equals a. So in this case, our x equals a is 2. Um, oh, that equals, oh, um, okay. Ooh, wow, dude, this is hard. No, I mean, I think this is really easy. F of x, yes, would have an output of 1. That's what we're trying to find. But why? Why are we trying to find that? Oh, no, 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 no. I see. Oh, no. Okay, I completely see now. Cool. So let's see. So we have f of x equals this. So, mm, what value of x here would make this equal to 2? I think, right? I think that's what it said. Um, yeah, so here we need f of x equals 2x plus cosine of 3x, and that needs to equal the input of the inverse. Oh, interesting. Yes, the value of x in our original function, that one plugged into our original function, equals the input of the inverse. I see. Okay. So, yeah, the value of x, that when we plug in the original function, you get the value of the input of the inverse function. I see. Okay. Well, oh, okay. Well, yeah, the value of x. So simply solve for x. So we have so if you square everything, you get x minus 2 equals 4. Therefore, x equals 6. Okay. So 6 is the value of x. You get Oh, guys, watch. I mean, I think this is incredibly simple, but here. So, gotcha. I totally see now. X equals 6 is the value you get by plugging. Okay, here. So x equals 6 is the value you plug in here to get 2. Or in other words, the value you plug in to get the input. And finally, x equals 6 is thus the output because you plug in 6 here, you get the input. Cool. So therefore, this is 6. Um, and then to find the inverse, well, I so we just do our formula thing. So we do 1 over f prime of f inverse at x equals a. And our a is 2. So we need to find the derivative of f inverse of 2. That's our a. So this is equal to, okay, in fact, here, I'm just gonna 2. There we go. That's beautiful. So this is equal to 1 over f prime of 6. Simply replaced. Simply replaced. F inverse of 2 is 6. Yeah, that's a fact. You can go back in the live stream and find out how we got to that number, but that's a fact. So then F inverse of 6. Let's go. So what's sorry, F prime of 6. Um Gotcha. So all right. I was tempted to do just like get the derivative of 6, but no, that's obviously stupid. So yeah, we go back to our original function, f of x equals square root of x minus 2. And yeah, f prime of x, well, is going to be f prime of 6 equals the, okay, no, sorry. Yeah, I'm not going to do a prime yet. Yeah, f of 6. No, 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 I'm sorry. F prime of x equals 1 half x minus 2 to the power of negative 1 half. There we go. Cool. And then finally plugging in, plugging in 6, you get 1 half. Right? Yeah. Easy. So therefore, this is equal to 1 over 1 half 4 to the power of negative 1/2. Cool. You go back here and you plug that in like you know what you beautiful, bro. And now part C, calculate the inverse of x and state domain. Oh, and state the domain and range of the inverse of f. Okay. Oh, so they're asking us for like a general inverse function. I see. So, oh well, I mean, huh. I'm confused. Hold on. Okay. So, all right, I'm just going to rewrite the equation. Equals, let's say y. So solving for x, you get y squared plus 2. I'm, am I doing this right? I mean, I sure hope I am. Is state the domain and range of the inverse of f of x. Use interval notation. If needed, enter in for infinity and negative n for negative infinity. Huh. Oh boy. I mean, I think I'm doing. Oh, you got this? Yeah. Okay, thank you. Sup, bro? Love from Lithuania. All right, man. Lithuania. Wait, hold on. Yeah, there you go. I think I've heard of that country. That's awesome, man. I think it's a beautiful country, actually. Very cool. How was it living there? Yeah, that was like a part of the Soviet Union one time. Okay. How long have you been growing hair? Well, I think I began growing hair when I was born. I mean, I eventually cut it, but I think so. I mean, how about you? How long have you been growing hair? All right, I was kidding. Here, I'll go back. Sorry, I just need to finish this question. Um, let's see. Let's see. Okay. Mm, all right. Calculate the inverse of f of x. Okay. And state. This is obvious. I'm not sure. I think I'm missing something. Oh wait, hold on. Is it just like, no, inverse of a function? Oh, okay. Wait, hold on. Um. Yeah, you do like y equals, right? Yeah, so I think I'm correct. Oh, y squared plus 2. Y squared plus 2. And the domain, well, let's see. We are the domain of that. Okay. So we have f of x equals this. So what values of x don't work in this function? Let's see. Um, can you do square root of 0? Yeah, I think you can, right? Can you do square root of a negative number? That probably it won't work, right? You'll get like an imaginary number. So I mean, I think the answer is going to be something like negative infinity to 2, whoops, 2 union to uh infinity. Whoops, there you go. why isn't this? Oh, why is not defined? Oh, okay. Oh, oh well, like f. Let's see, or how like f of x. Oh, it's like the output over here. So y is not defined. Oh, hmm. Am I missing anything obvious? Yeah, dude. I mean, I don't know if you guys see that I'm, I'm missing anything obvious here. Mm, so when you solve f of x equals x cubed plus 2, yeah, you do a y equals something. You enter that, it'll say that y is not defined. Like, can't you just say like output? Oh boy. All right, it's fine. I'll go solve for the range. So the range is gonna be, let's go back here. Our o- output. Wait for the, oh, so this is gonna be f like f inverse of y squared plus 2 equals x. I think that's what we get. So our range, everything, yeah. I think that's gonna be a negative infinity to infinity, right? To unless I'm missing anything. You know, I think we're good. Oh wait, whoops, no, sorry, this is wrong. Um, wait, no, we need to get x. Oh boy. Oh no, yeah, sorry, this is good. This is good. It's 2 equals x. Is incorrect. Wait, are you telling me the answer or what? Oh boy. Your left endpoint is incorrect. And what do we get for that? All right, what happens if we just press submit? So we get this correct, but then we get these. Oh my goodness, dude, what's going on? Oh, what's that? All right, this is similar. Yeah, how do you, I mean, we're at y equals, dude, you are using y. Why can't I use y? Come on, bro. That's the function. I'm so confused right now. Why can I not use y? Am I like missing anything? Yes, the inverse function is in terms of x, though. In terms of x. Oh, okay. Oh, so I mean, so is the x of the inverse function like the? Oh, hold on. Oh, okay. I mean, I find it a little bit confusing since here we have f of um, sorry, the inverse f inverse of x when this x is like the y of this. So if it's written in terms of x, huh, is written in terms of x though. Let me know. Written in terms of x. But how? how is this written in terms of x? If like we have x right here. All right, all right. I think you might be honest. Some pop out chat. If we just do that here, I'll just put it back. Oh, what did I do? Steps. Can I put this back or not? Oh, come on. What did I do? It's right there. Okay, I think of it like this. For example, does f of x equals y plus? Yeah, yeah, I think that makes sense. Oh, wait, hold on. Wait, what? No. Wait. Uh, f of x equals. Okay. All right. You're right. Oh, okay. Well, my bad. You are completely right. My bad. I see. Yeah. All right. All right. Thank you. Thank you. That makes a lot more sense. Wait, but if that's the case, then hmm. So do I? Oh my gosh. We but minus two equals. All right. So I know that this equals to y, like the output, but then I want to solve for x. Um. Boy. Wow. X equals y 2. Oh boy. Um. All right. So okay. Wait, hold on. So if I have like f of a equals b, I know that f inverse of b equals a. So I know that x equals this. Oh, I see. I see. Okay. All right. So all right. I think that this is incorrect. So I think I'll have something like f inverse of square root of x minus 2 equals x. I think that makes more sense. Um, yeah, so f of a, so this is like the x, and I'll get b. And then f inverse of this is going to get that. Okay. So, oh boy, wow. X and y are just variables. Don't give them any more meaning. Okay, okay. Hold on. So, oh, but they do y equals, okay. So, oh, interchange x and y. I see. So, am I supposed to have something like that? I see. Huh. So, you interchange x and y. Huh. All right. I think I'm spending a little too much time on this, or I'll just continue. So, if I have x squared plus 2, uh, so the domain will be, yeah, well, everything works, right? Nothing does not work. But then the range, well, I think I can only have 2. Hold on. If I have 0 squared or anything squared, I'll get minimum 2. So 2 to infinity. I think this is correct then. Oh, that's not correct. Huh. So the domain. Yeah. input values. Why is that not negative infinity to infinity? Uh, to infinity. Oh yeah, how is that not negative infinity to infinity? I'm confused. I feel so dumb right now. Domain. Hmm. Negative infinity to infinity. Is there any value that does not work here? Oh, no way. Oh, no way I actually got that wrong. Yeah. You, come on, bro. Zero squared, but you can't do. Oh, what? No. What am I doing? Wow. No, you can do anything. Yeah, a negative infinity. Oh, wait, hold on. Left endpoint is incorrect. What do you mean by that? If I do that, will you say infinity? No, that doesn't work. What if I do? Don't worry, you just missed a one important step. Okay. Mm. Well, thank you for your patience. I really appreciate it. I know it must be tough. Me just getting all these errors here. Okay. All right. All right. Here, I think I'm just gonna look at the solution equals C, and that implies that the input equals f of the output. I see. Right. Then we need to find c such that the square root of c minus 1 equals 1. Wait, and that's the x minus 1. That the um so yeah, so f of x equals that. We need to make that equal to the output. Okay. Squaring both sides and solving for c, we get 2. According to the theorem, we get f prime of 2. Solve and we get 2. Okay. We write y equals square root of x minus 1. Then we solve the equation for x. X equals y squared plus 1. Yeah, so what we did is just square and then add 1 to the other side. Finally, we interchange x and y. Therefore, the inverse function is going to equal that. The function f has domain 1 to infinity. Whoa. Why 1? Can't you do a 0 squared or negative 1 squared? Oh boy, what am I missing? Blah. Yeah, we don't talk about it there, do we? But why 0? I'm so confused. Oh, wait. No. I think that actually makes sense. 1 to infinity, a domain 1 to infinity. Okay. Uh oh, no, I see. I see. We have we have a parabola. Oh, so we have to restrict the domain so it passes the horizontal line test. Oh, that makes so much more sense. And range is not, yeah, because if it's 1, 1 squared is 2. No, sorry, 1 squared is 1, 1 plus 1 is 2. Wait, and how did we get 0 in the range? I think this is wrong. You can't get 0 here. You know, that's actually impossible. Unless, so if that's the case, yeah, squared plus 2. So negative infinity does not work at all. So we have something like 0, I think. But then instead of that, you're not or you include 0. And that means that, oh wait, but then we have that. Oh, it finally works now. Interesting. And then the range from, well, it's 0. 0 squared, you get 2. 2 to infinity, but why does that not work? 2. Oh, sorry. I think 2 squared. Sorry, no, 0 squared 2. So you must get there. Oh, yeah. Well, I guess you included 2, right? Is that what they want? Probably, I guess. Oh, would you look at that? Oof. That was a tough problem, even though I think it was really simple. Pretty smart. It's 1 to infinite. Oh, it's 1 to in. That's what I thought at first. Or maybe it does not include 1. It begins from 2. Hmm. Crazy. I mean, we still got 2 more problems to complete, and we have 42 minutes. We got 6 viewers now. And that's crazy. Thanks, guys, for. Yeah, you got it. I got it. Yay. Thank you very much for your help, by the way. I mean, it helped me a lot. Yeah, especially yeah, the inverse is written in terms of x. That helped a lot. Thank you. But 9 people. Let's go. Yes, guys. All right. Let's finish. Let's finish this homework. So, in here, I'm just gonna. Let's do this. Thank you guys for your help. Let's see. So, let's do this intuitively. So we have consider the function. Whoops. I'll zoom out maybe a little bit. F of x equals 8 over x minus 3. What this thing is moving. For x greater than 3. I see. Okay. Sure. Then we need to find f inverse of 4. So we need to find f inverse of 4. Gotcha. Okay. So let's see. What did we learn? So implies that the f inverse equals a. If the input of the input of the original function is going to be the output of the inverse function. So we know that f inverse of 4 is 8 over x minus 3, I think. Yeah. Oh, all right. No, that's not right. Or is it? Oh, no, no. Wait, hold on. I mean, okay. I see. Oh, hold on. Wait, no. I think what is true is that f inverse of x, um, sorry, f inverse of 8 over x minus 3 equals x. I think that's that is what's true. So we need to find x inverse of 4. Oh, I see. So we got to find a value of x here, like, or I don't know, here equal to 4. I think. I think that that's what we're supposed to do. Um, and then we know. Oh, yes. And if we can do that, okay. So this is the. I think it looks ugly. So in order to find this, we simply got to find a value of x that makes that equal to 4. Oh, wow, dude. Wow, this topic is like a little bit confusing. Let's make f of x equals y and solve. Let's do that. I'm thinking way too much. You're right. You're completely right. Yeah, what was it? F of x equal to y. Okay, so and solve for x. All right, well, let's do this. Y equals 3. Solve for x. So we have x minus 3 times y equals 8. X y minus 3y equals 8. Whoops. Y equals 8 plus 3y, I think, right? Yeah. And then x equals 8 over y. Oh, we got that right, right? Yeah, we got that right. Perfect. So this is what we got. Yeah, no, that box is not cool. So x equals 8 over y plus 3. So we found the x value That what? um. All right. So we plug this in here. So we'll get something like x over the reciprocal. You get y. Oh, you plug this in. Whoops. Plug this in to f of x. You get y. Oh, we found the inverse function, right? Yeah. That's literally it, right? Yeah. Oh, of course. I see. We plug this in here and we get x. Okay. Oh, that's genius. Thank you. Yeah. So, oh, but then we need to do 4. So, okay. That's what does that mean? Okay. So, I mean, I think the thing that I'm confused is like that's the only thing that like makes me confused. But no, oh, okay. Hmm. So we know that x equals 8 over y plus 3. Um, but what's next, bro? Hold on. So, okay, easy. So, determine f inverse of 1 for f of x equals 2x plus cosine of 3x. Determine f, so we need to determine f inverse of 1. Right. So, what is f inverse of 1? The values of f of x that equal 1. A simple, right? Yeah. So, in this case, we're going to do the, what? Yeah, the output values of f of x that equal to 4. The output values of f of x that equal to 4. I see. Gotcha. So we need to do something that this equals to 4. And that's going to be the inverse function, I'm guessing. Um, sorry. So 2x plus cosine of 3x. We 1. And why is that important? Because the output of f of x must equal the input. Oh, so we must find the x values. I see. The x values. The x values. So what x values of this is equal to 4? Oh, well, I think that we simply plug this in and we get 4, right? So yeah, we plug this in, we get what do we get? 8. Yeah, so yeah, 8 over we just did this. 8 over 8y. Okay, y equals 4. Uh-huh. Yeah. So 8y plus 3. So that's going to be this is a very tough subject. What am I doing? 8 over y plus 3. Dude, that's where I'm going to cry. That's kidding. No, I'm not. Y. Okay. Y equals 4. So a 4. So do you plug? Um, equals 0. Oh, what does that give? Oh, no, guys. I'm complicating this so much. So therefore, plug this back in. Oh my. No, this is simple. Why am I complicating this? Equals 0. Mm-hmm. Yeah. What value of x makes 2x plus cosine of 3x equal to 1? The input of the inverse function. So, yeah, and that value is 0. Plugging in 0 there gives us that, okay? Um, f of x equals 2x plus cosine of 3x. I see. Wait, how long do we go on our live stream? Wow, an hour and 27 minutes. Hmm. Let's see. Wow, this is crazy, dude. I mean, I think this is good for the mind. We need to do some meditation. That's kidding. Let's see. Okay, so input. Okay, so what does that mean? So wait, f of x equals 8 over x minus 3. Okay, okay. So f of x equals 8 over x minus 3. And we need to find f inverse of 4. So what does that mean? So, so 4. Right. Per the definition. So we need to find a value of x that makes this equal to 4. Come on, man. Um, and that's 8. Oh, but what 8y? What is y? Oh, well, 8 over 4, right? 8 over 4. Yeah. Or, yeah, 4 minus 3, 7. 8 over 7, 8 over 7. Hold on. So if you do, all right, solve for x here. So we do 8 equals 4 times x minus 3. 8 equals 4x minus 12. 4x equals 8 plus so 20, and therefore x equals 5. Plugging in 5 to f of x makes the output equal to the input of the inverse function. So therefore x equals 5. That was so tough, but that was so good, guys. Let's go. Thanks for your help. Um, no, that's not correct. What do you mean that's not correct? No, dude, I swear, that's correct. No, no, yeah, I think this is correct. Okay, here. Oh, no, no, perfect. Well, we can just test. F of x equals output. The inverse function should have f of the output equals to the input of the of the original function. You plug in 4. Sorry, no, no, no. You plug in 5 here and you should get 4. That's oh my goodness. What, bro? No, well, x minus 3 should give like 2 or something, right? X minus 3 x equals 5. 5, yeah, no, x equals 5. Uh-huh, that's right. That's right. 5 minus 3 you get 2, 8 over 2 you get 4. F of x equals 8 over so f of a equals b. B. Okay. B. F of b. So 4 and 8 over x minus 3 are equal. B equals a. It's like mind-boggling a little bit. No, but I think we're good. I think we're good. Just put y equals 4. It's correct. Bro, that was crazy. It is correct. Yeah, yeah. Whoops. Thank you. Uh, oh, wait. Put y equals 4. I don't think it tells me. Wait, should I? No, no, no. I don't think to do that yet. Oh, hold on. I think I need to go to the bathroom. I'll be right back. And we're back. Oops, close my door. Okay, so now we got it to determine f inverse prime of 4. Oh my goodness. We have 27 minutes left and we're not even halfway in our homework. And we only got 3 problems. Dude, I thought this was going to be easy, but no. No, no, no. Okay, we got this. I mean, we need to do this. Oh my gosh. Was all of this necessary? I mean, probably we eventually got there. All right. So, we apply the rule. Let's do this. 1 over f prime of f inverse of a. Oh boy, let's do this. 1 over f inverse. Oh, well, yeah, wait, hold on. And this, we're trying to evaluate this at 4? At 4. Oh, okay. And viewing this intuitively, we see that. Oh, no. Sorry. We're just doing the derivative. No, I don't need to do that. My bad. My bad. 4. 4. Perfect. So 1 over f prime of, and we found out x equals 5. F prime of 5. And what's our function? 8 over x minus 3. 8 over x minus 3. Sorry, so f of x equals that. So therefore, x prime of 5 is going to equal 4. What? No, we're not supposed to do that, dude. We plug in 4. What are we doing? Equals. So what does that mean? 8 over 1. 8. The answer is 8. Crap. Sorry. No. Calculate f inverse of x and state the domain and range. All right, my favorite question. So, let's do it. Come on, here. So I'm just gonna. No. I don't need to. So we have y equals 8 over x minus 3. Plugging. No. So we have. Wait. What did we get? We had like a. Whatever. So yeah, x minus 3, y equals 8, xy minus axy equals 8 plus 3yx equals. Oh yeah, I already did this, I remember. Plus 3. Okay. And then replace, interchange x and y. So we get y equals 8 over x plus. Oh no, no, well, that actually makes sense because that's that function. We're just. No, it makes complete sense now. Plus 3. Domain. What's the domain here? Oh, what's wrong? Variable y. Oh, well, there you go. There you go. Domain. What's our domain here? Well, I mean, I think the domain can be anything, right? Oh, well, I mean, it can't be 0. Negative infinity to 0, union 0, all the way to infinity. Unless I'm missing anything. Yeah, no, that's perfect. Beautiful, bro. We don't have a parabola here, so we 8 over x, like 1 over x is gonna be like a line or something. So yeah, no, we're good. And the range, well, it can be like anything, right? Yeah, negative infinity all the way to infinity. Oh, well, this is wrong as well, dude. Where so 4. 4 minus 3 is 1. 8 over 1. Yeah. Wait, hold on. What was wrong? Oh, the derivative. I see. Uh, so we know that, whoops. We know that this is 5, right? 5. Uh-huh. So f prime of 5. So f prime of 5. So we know that f of x equals 8. Whoa, dude. Equals 8 over x minus 3. Dude, please. X minus 3. X minus 3. So, oh. Oh, dude, we forgot to do the derivative. F prime of x, well, yeah, a no quotient rule. We simply do, okay, here. Let's do it. So f prime of x is equal 8 to the power of negative 1. Love this prime. So therefore, we have 8, or like negative 8, x minus 3 to the power of negative 2. And plugging in 4, that's what they want us to plug in. Negative 8, 1 to the power of negative 2. Right, yeah. X minus 2. Sorry, x minus 3. 4 minus 3, 1. That's literally negative 8. Negative 8. I think that's right. And we get, that's not right as well. Oh, wow. This is tough. What's going on? Did I do the, the derivative wrong or what? Prime of x. Yeah, 8 is a constant. So no quotient rule. To the power of negative 1. So bring it negative 1. 8 times negative 1 is negative 8. And this becomes negative 2. By plugging in 4. Wait, they want to do, oh my. What am I doing? We got to plug in 5. We got to plug in 5 here. So, no. Hold on. So, we get 2 to the power of negative 2. There we go. I could have simplified that, but I don't want to make like any algebraic error. So, 2 to the power of negative 2. There we go. Yeah, I mean, that should be correct, right? That's not correct. Five minus 3, that's 2, right? How long are we going? 1 hour and 41 minutes? Why are you replacing x by 2? Negative 8 over 2x. 10 people aren't here. Whoa. Thanks for joining, guys. Watch me get cooked by inverse functions. Negative 1/2 is the answer. 5/2. Oh, no, not 2x. Oh, x squared. My bad. X squared. Gotcha. Okay, here. I believe you. I just want to see how we got there. Hold on. It's asking me to plug in 4. Do I plug in 5 or 4? All right. 1 over f prime of f negative 1. 4. This is equal to 1 over f prime of 5. We got 5, right? Yeah, 5. All right. Very simple. F of x equals 8 over x minus 3. You plug in 5. Oh, wait, my bad. So first, let's calculate the derivative. 8 times x minus 3 to the power of negative 1. So the derivative is going to be, oh, whoops, nope, that's not right. So we do that. 8 times negative 1. I see where this can go wrong. Negative 3 equals negative 8 x minus 3 to the power of negative 2. And you plug in what? You want to find f prime of 5. So f prime of 5 is going to be negative 8, 2 to the power of negative 2. Is that not what we have? I'm not sure I understand. F inverse first, then derivative. No, I mean, but I think the method they want me doing here is first, I think is find the inverse, and then we apply a formula where something like 1 over f prime of the inverse at x equals a or something. Step 1, find the derivative. Plug it, done. 8 over x plus 3. You good, bro? Wow. Got 12 people seeing me here. Should I have named this video "Watch Me Get like cooked by inverse functions"? Here, how does Wikipedia do it? Right. No. I think we understand, but I just don't see where I'm getting is wrong. Your inverse function is wrong, but the thing says otherwise, though. Are you sure it's wrong? I mean, it has happened that like my homework thing is wrong. Oh, just put in negative 1/2. Okay, so like here, rather than 5, the inverse function is 8 over x plus 3, but it's asking me to evaluate at 4. So I plug in x equals 4, right? All right, 5 over 2. I like that. Oh, on B. Okay. So this is 5 over 2. Well, that seems correct. And no, that's not correct either. For derivative 1, try 5/2. Negative 1/2. That says it's correct, dude. Oh wait, do you want us to simplify more? Hold on. I mean, I know that this like a negative 8 times 1 over 4. I think, right? 2 to the power. Yeah. So negative 8. That's the same thing. I don't get what's going on. Yeah, a negative 1/2. No, I see. Yeah, you're right. But like, why? Why did it say the other thing was wrong? What? Okay, it's fine. All right. We get it. We just need the domain and the range. Oh my goodness, guys. It's push-up time. Oh, come on. Just need to get some stimulation, you know. All right. We're good. We're good now, guys. We're good. Come on. We just need to get this domain in this range. Oh my gosh, guys. So, what works? The domain. Let's see. So 8 over x plus 3. That's like I mean, it'll pass the horizontal line test from negative, but we know that we can have 0. We can, because we have a plus 3 in here. So we're good. We don't, but that'll be, wait, hold on. A over 0 is infinity, regardless if we have a plus 3. So can we allow a 0 or not? Oh, okay. Domain. Mm, okay, what if we just take out 0 and we just do like that? Domain. I mean, I understand what the domain is, but why is this wrong, dude? I mean, if I plug in 0, A over 0, that's going to be like infinity, isn't it? Or like undefined? Oh, wait, no. I think I can't do that though. Or no? Is it canvas? Yes. Well, this is Edfinity, but my um yes, this is a canvas. That's right. There's a plus x equals 0. Yeah, it's correct. Why is it saying it's incorrect? I knew it. 0 all the way to infinity. Oh, oh, okay. What about the range? Let's do the range. Here, I'm just gonna graph this function in Desmos. 8 over x plus 3. Oh, interesting, bro. So the range, hold on, the y values. Yeah, it works for everything, right? Oh, except what? Except like 2.2 or something? Whoops. Here, I'm just gonna close that for a second. The left endpoint is correct, is incorrect. Okay. The range. Well, dude, I don't know. I mean, unless or like I'm missing anything. Uh, mm, let's see. Domain 0 infinity, range 9 to infinity. Hmm. All right. I think I see a pattern. You can't have it on both sides, so just gonna. And I feel so guilty right now. Kind of like, okay. How about this? So 0. We should have. That's gonna be what? Oh, hold on. So what if we like include infinity? What is this gonna be like 1? I think. Oh, hold on. That's also wrong. Oh, to 3. Oh wait, hold on. This is obvious. No, no way, no way. So you can't do 3. A over 3 plus 3. Range. Oh, hold on. We're looking at range right now. Oh well, I mean, yeah, it makes sense. Uh, 3. Negative infinity to 3 and 3 all the way to infinity. Not square brackets, no. Here. Let me put that. Okay. Getting a little desperate here. 3 all the way to 3 all the way to infinity. And that doesn't work? What? I don't have any of those though. Oh, you. Okay, so it looks like 0 to infinity is correct. But this one is not. Um, let's see. Mm, let's see. Hold on. Wow, dude. I am gonna be screwed for the test if I don't understand. Yeah, I need to do many more problems. You're completely right. You're so right. Yeah. To 3. Oh boy. Uh what's the okay. Should he pull up AI? No, I don't want to do that though. What do you get here? Zero to infinity. Here, what if I put 0, 0 to or 3 to infinity? Oh, that's probably it, right? Okay. All right. So the takeaway from this problem: only do positive numbers. Because if we do negative numbers, then bad things will happen. Okay. Okay. I see. I see. Here. Get up. I see. Okay. All right. Well, we got one problem left. And here I'm determined to understand everything so that I can do decent on the quiz. Wow, the comment section is exploding. Let's go, guys. Try the positive. The positive side. Oh no, negative 3 to 3. Huh. Wait, was it the exact same problem? 3. Yeah. I could have done that. Don't do that. Take away. No, I don't do that. Take away. No. Yes, I did finish my burrito. I did. I finished it like an hour ago. So I just wanted to focus. Bro's cooked. All right. Here, we got one. Oh, we got a video. Let's go. Oh, we got a video to watch. So they can get we got 14 people on the live stream. Welcome. Welcome. Oh my, what? 17 people? That's insane. Wow. Thanks everyone for joining. Let's go. Yeah, we have one more problem to complete. And yeah, and how long do we go? We go 1 hour and 57 minutes in this live stream. Oh my gosh, guys. Wow. This is insane. These problems. I mean, I was laughing at it. And then yeah, I can't be laughing at this problem. Well, before I begin, I just want to chat with you guys. How are you guys doing? Are you guys doing well? The school going well? To me, quit the class and start your YouTube career. I know, dude, I can't do that. I mean, in my last exam, I got like a 94. I did pretty decent. Uh, for real, a good man. You guys think I would do well on a YouTube? I don't know. I mean, I'm producing like a live stream right here. How are you doing? I'm doing good. I thank you for asking. I mean, I'm having fun with you guys here. It's a lot of fun. Are you guys doing like any sports, any activities right now? Anything? Okay. Well, I hope you guys have a good day. But we're not done yet because we have one more problem to complete. Let's do this. Wait, hold on. Okay, I kind of want to see. All right, I kind of want to do it ourselves first, and then we'll watch the video if you have to, and hopefully, I mean, hopefully, there's no like a copyright. Uh, okay, so let's get rid of all of this, and let's finish this problem. Let's do it because guys, the people who did not quit were like Alexander the Great. He conquered the largest empire in history by age 30. We got to be like this guy. What's his name? Oh yeah, the founder of the Roman Empire. Yeah, we got to be like that guy. I don't know if they were like if they had trouble doing calculus. You know, we all got to go through that. I want to see you eat a burrito in one bite. You think I can do that? I don't know. College admissions are cooking me. College admissions. I think it's stressful. Yeah, it's tough. Well, I wish you the best of luck. I mean, yeah, they're stressful, but like they're a good experience. It's good for the character. So I hope you have a very good experience. I hope that you grow intellectually, academically, dude. Okay. Yeah, man. Complete the square. Okay. All right. Let's do this. So we have for each of the given functions f of x, find the derivative f inverse prime of c at a given point c. Oh, you're right. We are cooked. No. We got this. First, finding a equals f inverse of c. Oh my. Okay. Oh wow, dude. Here. What if I do this? If I put it here, we just begin. So we have. Let's zoom in. Perfect. Okay. So I'm just gonna zoom out a little bit. For each of the given functions, all right, so we have a given function right here and then a given one right here. Okay. Find the derivative f inverse prime of c. Okay. Yeah, so that's x equals c. At a given point c, first finding a equals f inverse of c. All right, so I think the way I see this is our c is no, I'm sorry. Um No, just kidding. Scratch that. So I'm just going to write down the function and hopefully something sparks up. We have f of x equals 4x. Whoops. F of x equals 4x plus 8x to the power of 7. F of x equals 4x plus 8. And then we need to do c equals negative 12. Oh, so we need to find the derivative. Okay, I understand. So we need to evaluate at c equals negative 12. So, just gonna get closer. So first, I think the first step is finding. Here, I'm just gonna widen this. Our first step, guys, is hitting that subscribe button, and then we do f inverse of x, and we get. So, goodness, dude. So we have f inverse of 4x plus 8x to the power of 7 equals x. Well, that's like the definition. Yeah, we're lost. Okay, well, I'm just gonna watch this video. Uh, f of a equals c. Okay. Yeah. All right. So we have a equals f inverse of c. So f of inverse of c is a, and that implies that f of a equals c. Okay, hold on. So, yes. Right. Okay, so first, let's understand what they're asking us. For each of the given functions f of x, find the derivative f inverse prime of c at a given point c. First, finding a equals. Okay, wait, so what was the last part he said? To find a such that f of a. What? A equals. Oh my goodness, dude. Wow. A equals to f inverse of c. Oh, I get it. You get c. I see. Okay, cool. So we need to find a value a that equals f inverse of -13. A value a that equals f inverse of -13. That also equals to f of a equals. What are we saying, dude? Okay. Yeah. Cap. I mean, no, that's all right. That's not cap. Hold on. All right, we're gonna cross a crash out, but no, this is good. This is good. So f of a equals -13. That's what we need to find, right? Mm, oh boy. Wow. I mean, I understand what he's saying, but I'm trying to understand why. We're trying to do that so we can say that f inverse of -13 equals that a. Oh, no, 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 no. I'm sorry. So we're finding the value to in. Oh, gotcha. No, cool. Okay, where are we? We're good. So hold on. So um, we have f of a equal, bro. Stop. Equal to c. Equal to c, and we need to find f inverse of c equals to a. I think. Anyways, something like that. So perfect. Here. So the function we're given is this, I think. F of a equal to c. So we know that f of x equals 4x plus 8x to the power of 7. That's our a. Equals to -12. That's our c. Okay. Um wait, no, that's not what? What am I saying? Is that our a? What does the comment section say? Trial and error. Yes. Cool. Thank you. Yeah. These are very good experiences. Good, a good, a good trial and error. So, whoops, that. Wait, are we still? Yeah. Okay, cool. Where are we? Oh no, I see. Yeah, they never claimed that the function is equal to negative 12. I see. Okay. What we do know though is that we know that f of a, so I'm just gonna take all this off though. And so we know that f of a should equal negative 12. Perfect. So now we just gotta find what the a is. Okay. Or what value of wait, hold on. So is that saying what value of x in and f of x equals 4x plus 8x to the power of 7 equals negative 12? Well, I have no idea, but we're doing it anyway. So, equals 12. Now, my instinct tells me to solve for x. So, let's factor x out of there. 4 plus 8x to the power of 6. Oh, wait, but we need all the x's, though, right? Oh, wow. How do we solve for x then? All right, hold on. So I know that we have x here, 8. We have that, but we still got that x there. So that's not what x is. That's it. I'm doing the video again. Thought we had it, but yeah, yeah, that's right. Luck. All right, we are relying on luck. Okay, that's what we're doing. So I think we were doing the right steps, but we just need to rely on luck. Yeah, that's right. Sometimes success is not always hard work. So 4x plus 8x to the power of 7 equals 12. What do we do? So, all right. So if x is 1, we have 4 plus 8. Oh, okay. Awesome, dude. Okay. So, awesome. So when x equals 1, that's right. So we know that, f of 1 equals negative 12. And therefore, a equals 1 because we have said before that f of a must equal negative 12. Would you look at that? Okay. So then, um, f inverse prime of c. Okay. Let's see. So what's it asking us? So let's go back here. So it's asking us for, okay, no. So we know that f of a equals c. And we just found out that f of 1 equals negative 12. So now we need to find f inverse prime of c. So that's f inverse prime of negative 12. So it's asking us for f inverse, uh, wait, so that's prime of negative 12. Here, let's write this down neater. F inverse prime of negative 12. Of negative 12. Ah. Well, by definition, this must be 1, right? Oh, wait, but sorry. Okay. No. My bad. So I think what we know that f inverse of negative 12 equals, well, 1 by definition, right? So um, we apply the formula. Gotcha. F prime of the inverse at x equals a. So that'll be no. I'm sorry. No, we want to find out at c. So that's negative 12. Gotcha. And we found out, whoops, that this equals 1. So we want 1 over f prime of 1. We know that so f of x equals 4x plus 8x to the power of 7. And then finally f of 1. No, I'm sorry. Finding the derivative first. We should do that first. 4x plus 8 times 7 is what, like 56? 8 times 7, 56 or 54? 56, I think, right? X to the power of 6. Finally, f prime of 1. Wait, dude, hold on. 8 times 7. 8 times 7. 56, yeah. Oh, wait, what happened? Oh, phew. We get 4 plus 56, and that's equal to 60. 60. I see. So 1 over 60? What 1 over 60 is that what it's asking us? I think, right? Yeah. Unless you got anything wrong. Here, I'm just gonna check if my answers are correct. Ooh. Oh, A is not correct. Wait, but 1 over 60 is correct. Wait, A is not correct? What does that mean? Wait, so how did we get 1 over 60? Sure that's correct? I mean, okay. Oh boy. Why is A incorrect, dude? I mean, are we plugged in 1? Okay, hold on. Where are we? So F A equals C equals A. Right. So that means that there's a certain A that f of x evaluated at A equals to negative 12. And f of 1 equals, oh, it equals 12, not negative 12. Interesting. So what should A be then? A should be, so if it's negative 1, so we have negative 4 minus 2 because 7 is odd. Awesome. So this should be negative. Wait, but why is 1 over 60 correct then? So if we evaluate at negative 1, so we get, oh, x to the power of 6, negative 1 to the power of 6 is still even. Sorry, a positive 1. So that equals 1 over 60. I see. Okay. Oh, we're cooking, guys. Okay. And I think we're understanding a little bit more how this goes. And then finally, we have, so we will do this again, but with a different function. F of x equals x squared. Perfect. Oh, no, my bad. We're not done yet. I was impulsive. 11x plus 36. Well, still, we have a parabola, so that means that we'll have to restrict our domain. On the interval 5.5 to infinity, including 5.5, at c equals 8. I see. Okay. Ice cream. Gotcha. So we need a certain x value, let's call it A, which plugged into our equation equals 8. Right. And let's try to get lucky. If we plug in 1 minus 11, we get negative 10, negative. Okay, so that doesn't work. We get like 26 or something. We need to get 8. So how about we plug in 2? 4 minus 22. 4 minus 22 is going to be like negative 18. Negative 18 plus 36 is 18. So no. We plug in 3. 3 squared is 9. 9 minus 33 is going to be uh 24. 20 negative 24 plus 36 is like 12. Oh, I see. We have a pattern. So I mean it's probably going to be like a equals 4 or something because we're yeah, 4 squared 16. 16 minus 44. Wait, 16 minus 44. That's going to be 28. And 20 negative 28. Negative 28 plus 36 is 8. Awesome. So A equals 4. Perfect. And now um calculating our inverse derivative. Oh wait, hold on. But what was our inverse though? Our inverse, so of negative 1 of 4. No. My bad. Of wait, f of a equals c, so f of c, 8 equals 4 because 4 is the input of f of x to get 8, and 8 is the input of the inverse of f of x to get 4. That makes sense. The logic is consistent. So now we do 1 over. Wow, we're almost done. Do you guys feel it? Do you guys see the light? F prime of, yeah, well, I'll write it down. Negative 1 of, we want of, we're about at 8. No, wait, no. Yeah, at 8, right. And then we do this equals to 1 over f prime of 4. Yeah, we're evaluating at 8. And f prime of 4, well, yeah. So we have 4 squared minus 11 times 4. Wait, no, sorry. No. That's not what we're doing. So we have f of x equals x squared minus 11x plus f 36. F prime of x equals 2x minus 11. Finally, f prime of 4 equals 8 minus 11. Yeah, equals negative 3. So 1 over negative 3. That's wrong? Oh, no. Oh, what did we get wrong? Hold on. We're so close. I can feel it. I can feel it that we're so close. Just we must have gotten something dumb here. Uh 4. 16. 16 minus 44. 16 minus 44. A negative 28. Yes. And we get 8. A c equals 8. Perfect. Okay. So a equals 4. So f inverse of 8 thus equals 4. Right. Uh-huh. Okay, so we must have gotten something. Wait, but why does it say that a is wrong? Oh, so can we say that the inverse does not exist because it is not it is not on our interval? It's like it does first standing a equals inverse of c. Mm. Oh boy. Oh dude, I'm stumped. Quadratic formula. Why? We're not trying to find some roots here though. Wow, you guys are cooking here in these comment sections. Oh my goodness. Yeah. No, this is calculus 1. I'm just seeing diverse functions. Hey, what's up? Not even close? Yeah. I mean, we're so close. How long we 2 hours and 25 minutes. That's crazy, dude. Oh, here, should we continue watching the video? Equals equals what? Equals, oh, A, right? And what is A? Oh, minus 1, right? Yeah. Why didn't oh, wait, hold on. But then if you go to the second function, I see. No, oh, you're right, because we have a quadratic. So, 2 binomials then, right? Hold on. So, what are we trying to find? Uh, 2 values that equal sorry, 2 values of x. Okay, hold on. Yeah, so x squared minus 11x plus dude, wow, that's a little ugly. So, we're trying to find wait, so okay, x squared minus 11x plus 36. All right, plus a 36 that is must be equal to 8. All right. How do we factor this thing? So but why do we want to factor it? We're not trying to find a values of x that makes this equal to 0. Wait, so what does he do here? So he makes this equal to 0. Oh, so he subtracts. Oh, smart. No, that's actually kind of smart. Yeah, so we get x squared minus 11x minus 28. So, and that's equal to 0. So you factor, you get, let's see, that add to negative 11, then that multiply to negative 28. So that, how about like a 4 and 7? Oh, I'll let you go. X plus 4x minus 7. Hold on. 4 plus minus, oh, wait, no. I'm sorry. That doesn't work. So, wait, how about, um, I mean, a 4 and 7. Hold on. If you do positive, yeah, positive won't work. If you do, so if we do plus 4 x minus 7. So 4 minus 7. Yeah, no, that does not work. But it will work for negative 28. If you do negative 4 minus 7, that's negative 11, but you won't get negative 28. Oh my goodness, dude. Hold on. So, what if we do like hmm 28? That's 2 and 14. Oh wait, that might work. 2 minus 14 is negative 12, not negative 11. So no, that doesn't work. How about 4 no, sorry. 3, no, 5, 6. Oh wow. Um Here, what are the factors of 11? Whoops. 11, we have 2, 3, 4, 5, 6, 7. All right, let's quadratic formula. So, negative b plus or minus square root of b squared minus 4ac over 2a. So we have 11 plus or minus square root of what? 121? Negative 11, yeah. Minus 4 times 1 times negative 28. See. Is that what we get? Yeah. Over 2. This is equal to, oh, wait, and this is, oh, yeah, 11. 11 plus or minus 4 times negative 28. All right. So 10 times negative 28 is negative 2. Oh, sorry, but negative 4. So 280, 140, 140, 120, 120. Wait, sorry, 140, 112. 121 plus 112 over 2. Uh, 11 plus or minus square root of, and yeah, 121. 221, 231, 233. For real? Yeah, we can't square root that. Oh, did we get something wrong? 4 times 28, 12, 133, square root of 233. Wow, we're so stumped. Oh, it's already. Oh boy. -7, a -4. Oh, dude, oh no, dude, I promise I'm not using AI at all. That one web solving the Q, where? No, I mean here these are all the tabs I've opened. I don't have anything else here. That one web solving. Oops. All right, here. Oh, let's finish this. We just got to finish this right here. Okay, so I believe you had it easy. I can't factor like that. Can I? No. I mean, yeah, a quadratic formula obviously doesn't work. Okay, we have 11. 11 squared is 121 minus 4 times a, and a is 1. So -4 times c, -28. -4 times -28. That's -12. Sorry, that's 12. 112. I mean, I have a feeling I'm supposed to get 9. Why are the negatives not cool? B squared. -11 squared is going to be 121. Oh, gosh. Why did we do that, dude? It's positive 28. Oh, no. All right. Well, we found our mistake. Here. I'm just going to go here. Whoops. So we have 11. Do we have 11? Yeah. 11 plus or minus square root of 9 over 2. Thank goodness. Oh, okay. So that's 20 over 2 equals 10. And 2 over 2, that's equal 1. 10 and 1. So what does that mean? Well, okay, so just 10, 1. X equals 10, 1, comma 10. What else we got? So what does that mean? Why is that important? So those are values. Wait, okay. So we plug those values in, we get 0. But we're supposed to get 8. Okay, so do we just like Add 8 back? Or just counts? I see, okay. No, it just counts. So 5.5, that is our interval. So we're only going to regard 10. 10, okay. So if we have 10, all right, let's go back. Where are we? Come on, we're so close. We just needed this last part. F, um, oh, A equals 10. Yeah, 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 yeah. So F of 10, um, oh, I see. Okay. So C equals 8. Mm, so what do we do now? Hold on. So we have f of a, sorry, f of 10 equals 8. So negative 1, 8 equals, wait, what? So we found 10, but now we still, what, this 10, oh, well, that is what, okay, cool. So now we apply our formula. Now f prime of f negative 1 of 8. Oh, I see. Okay, cool. Now 1 over f prime of 10. Cool. Now we plug this in back into our original equation. X squared minus 11x plus a 36. That's f of x. F prime of x is going to be 2x minus 11. And then f prime of uh 10. 10. 10, right? Oh, guys, look, it's be real time. Say cheese. Um, cheese. Cool. Let's go. Where are we? So f of 10. We plug in 10, right? Yeah, 10 equals 20 minus 11, which equals, oh yeah, not 9. That's wrong as well, dude. Oh my. Oh. Oh my goodness. Oh. Oh, wait. No, wait, what? No, stop. Wait, dude, no. It's like 1 over 9, right? I 1 over 9. Uh, Hold on. So 2x minus 11. You plug in 10. 2 times 10 is 20. 20 minus 11 is 9. Wait, so 1 over 9 should be. Oh my gosh! What? Oh my. Dude. I, dude. No. What? 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 No. What's going on, bro? Dude, I thought that was correct. So 10, not even 10 is correct? Okay, well, yeah. If the inverse is not going to be correct, then 10 must not be correct. So negative, negative 112. 121 minus 112. That's going to give 9. 9, yeah. So the square root of 9 is 3. Oh, you got. You're kidding me. Did we get that wrong? All right, guys, I see what we got wrong. This is 11 plus minus 3 over 2. Oh no. So we have 14 over 2 equals 7. So we have 7. 7. 7 is one of the answers. Okay. And hopefully the other one gives something that's below 5.5. And 11 minus 3 is 8. 8 over 2 is 4. Perfect. So plugging 7 back in. 7. So this is f of 7. Plugging in 7. You get 2 times 7, 14. 14 minus 3, 1 over 3, I think, right? We did it. Oh, we did it. Let's go. All right, now all right, we did all of that. I'm going to delete all of that. Yeah. We did it. Let's go. Guys. Awesome. Okay, we got it. Yes, I know. Well, wow. Thank you all for your help. You guys were cooking it in the comments. Let's go. Thank you. I mean, that took so long. That's 2 hours and 40 minutes. That's crazy. 16 likes. I mean, I think that's like that's a bunch of likes for a single live stream. Thank you. Wow, that was insane, guys. Thank you very much. Those 3 problems took so long. This one, perfect. Oh, okay, but I need to review that material again because that, I mean, bros from. All right, well, thank you all for watching this live stream and for sticking with me for this entire 2 hours and 45 minutes. It was a lot of fun. Math on Sunday. Yeah, I mean, I had to kill some time, right? Thank you, everyone. I hope you all have a great day. Don't be impulsive with math and have fun. Yeah. So I go to ASU. I'm taking a calculus one right now. So, okay, I'll see you all next time. I hope you guys all have a great day, and I'll see you next time. Thank you.